Because the other thing about our animations is our animations are per frame collision. Our animations do have per frame collision, so if there was mathematical imprecision in the animation that caused it to penetrate the wall, and like we have stuff in here that's supposed to handle that, but if we get inconsistent math, like if I check this box and the checks are different all the time, then we might get some collision issues. Okay, so we're no longer getting these collision issues because the sweep test is actually returning things correctly and the overlap test is not. No, we still got it to happen once there. We got it to happen again. Is there any other place where we're doing anything that... Well, am I just gonna have to change this entire damn physics engine? I don't want to do that. The impact normal was 1 in the positive direction, so... Well, let's see if we can shim it out real quick. Hello, Toon Haze. And welcome. We are just dealing with stuck physics objects in Unreal, which is basically due to floating point math problems and raycast problems, which sucks. Apparently we're here to say things. Yes, things and stuff are what we're all about here. So I'm going to do a sweep movement object here. And our distance is going to be what do we have for sweeping in the movement utils? It's like sweep movement object, position, direction, distance, response. Position, direction, distance, response. Alright. Oh no. So we're gonna move ourselves. It's basically gonna be like this start position is gonna equal start position plus the collision dot hit dot impact normal multiplied by this like tiny number, and we're gonna like try to move ourselves out of this object, and we'll see if we can actually do it, so we don't get stuck in the damn wall. Thanks for hosting, Lucas. Bringing all the awesome stuff to the channel. Alright, so we're going to try to move ourselves out of this object. So we are initially stuck, and then we're going to basically try to move ourselves out of this object by these tiny little amounts, and we'll see if we can actually move ourselves out of the wall. Let's find out. This is as bad as the time you went without pants. Well, would you wear shorts instead? And then you were like, too cold? And then you're like, ah, man, it's too cold, I should have worn pants. So what is this thing getting angry about? Object, position, direction, distance. Sweep test response. I'm going crazy. I don't see this. Where is it? Sweep object. We definitely have, it takes an address of a sweep test response, so I should do address of collision. Is it really address of collision? Okay, yeah, it is. Alright, cool. Whitey is now 4 meters tall. Why is he 4 meters tall? Because you set the pixels wrong? That's probably why. Well, we're trying to make it so Bitey doesn't get stuck inside of things, because we found that he is getting stuck inside of walls. Well, The meter's tall and the pixel's tall, right next to each other. Well, hopefully at least the import-export stuff was working for you. You shouldn't have to mess with the perforce settings anymore. Like, you should be able to just... I optimized that, so you won't have to do a bunch of crazy stuff. Alright, so we got stuck, and then we were not able to get ourselves unstuck. Alright, so we're moving our object just a little bit. Or the emissives, I mean, if you do the mask thing there, it should line up exactly with those sprites. And you should be able to just like open up your sprite sheets in like Photoshop or whatever and just like see if they line up. Because if they line up in Photoshop, they'll line up in the game. Wait, what the hell? Okay, how does this make any sense? The overlap movement object. Well, did you actually check the, you know, what the sprite looks like? Like if it's a single eye emissive on the whole 2048 texture, then like it's going to be in harmony with your mask layer or whatever is not exporting the pixels. So make sure that when you're actually rendering in harmony, then it's actually rendering something there and not just rendering empty space. Because if it's rendering empty space, then it won't render into the sprite sheet, and if it doesn't render into the sprite sheet, it won't cut it properly. So are you not, do you not have your sync on right now, Adam? Because if you don't turn your sync on, I can't double check your file. Well, that's just because you're a big crybaby, Adam. You need to just get angry and yell about stuff. You should have seen the rivers of tears. Yeah, well, that's why I live in the States and he lives in Australia. He can cry all he wants and I can sleep like a baby. So these are all the emissives. And then we got the normal sprites going like that. So let's take a look at the ES crouch. Yeah, so I mean, you can see it right here, like this is just wrong. Like it needs to actually have Bitey and the rest inside of this frame for this to render properly. Like, let's see, if I crack open FATSAC, like this is what the ES dig looks like, and then when you render it, it looks like that. Yeah, it needs to render the pixels on there. So it should look something like this in the normal drawing layer, and then when you render it out, it should look something like this. Otherwise, it's all sorts of screwed up. So, like if I go here and I render it out, you know, it's obviously got the emissives in the right spot. We need to include not just the emissive, but if I run over to this guy, you can see we've got the negate hue saturation thing after we did the cut, and that's where we have our composite for both of them. So we've got like our Gaussian blur on just the eye layer for the blur, and that goes in there. So make sure not to leave everything on the floor, and you'll get it exported properly. So many streamers are crying about stuff all the time. It's true. It's definitely true. Also, Adam, if you didn't see, I've got the Photo Booth Pro level set up with even more stuff, because I don't know, you had the photo booth checked out, so I couldn't actually go mess with anything. But it's actually set up so this is the photo booth character. So if I go and import just the photo booth character, after it finishes all this source control shenaniganery, which there's nothing I can do about these because it's like at the add for the actual object. There's absolutely no input there to like turn off crap, so it's kind of just like, what the hell? Wow, Bitey's crouch is all sorts of screwed up, isn't it? No, it's just that it's below the ground. He's just so tall. But yeah, basically, it's just the emissive layer that's going crazy. But you can import somebody else into the photo booth area, and it'll replace all the characters and stuff like that. Of course, Bitey's too damn big for everything, so that's a completely different problem. Anyway, I'm gonna revert the photo booth stuff because I like FatSec in there. So something is screwed up here where this sweep object is not doing the same thing as this overlap movement object. Maybe it's this less than or equal to distance is what's going on with this. It is not actually getting checked. And I really don't know how more expensive the checks are for sweeping versus the checks are for overlapping. But obviously one of them is picking up the collisions when we're penetrating objects and the other is not, which is a major problem. So I'm going to have to see if at least the sweep component sdir is somewhat consistent or not. Malware bytes seems like a piece of shit if it's flagging everything as ransomware. It's like, oh my god, Unreal is ransomware. Oh my god, this file sync program is ransomware. Be like, it's ridiculous. Alright, well it looks like we have at least solved the initially stuck problem. So let's open up his movement stuff real quick and make it so we can actually dash again and make sure that that's not all screwed up. I mean, if you weren't on such an old version of Windows, you wouldn't have to deal with it. Like, the best antivirus on Windows is just updated Windows and Windows Defender, which is already on there. You just leave it on there. It's the best you can possibly get on Windows for antivirus. Alright, so we want to change this velocity back to, what was it, 5,000? I think it was 5,000. But I don't know what the best stuff on Windows 7 is. Alright, so it looks like we got that working properly. But it's going to be this running down a slope thing that's got us all screwed up. That whole thing. Alright, so we can now work on fixing that. At least now. Windows Defender is also highlighted. Yeah, it probably, like, Windows 7 still supported for at least the current bit. So, that's probably there. But a lot of antivirus stuff actually makes you less secure because it's not nearly as well tested as just the standard Windows stuff. And it can help for some things, like it's... A lot of the other antiviruses, I don't know, that I've seen, like when working at Amazon, we use Cylance. And Cylance pretty much worked by just isolating just about everything. And that made a lot of sense to use like an extra thing there because, well, we had, you know, a huge corporation with people's credit cards and crap like that. If anybody was going to get compromised, it's going to be one of the 300,000 employees that are working for you. Windows Defender got really good with what? Yeah. But especially for game development, all the antivirus stuff, except for like actually just Windows Defender, just it quarantines all the shit that you want and just does really terrible things. And be like, oh, your program downloads and then executes files? That's awful. We're gonna stop that. It slows down everything. A lot of antivirus will inject itself into your program at process startup and stuff like that, and override all the DLL hooks for calls into the operating system. So it'll slow down every part of your program. So yeah, we're definitely just getting initially stuck inside of stuff, and that's going to be because of our animations. Looks like it's going to be because of our animation states doing small things that are messed up. But we should be able to solve that. So the big thing that we need to do now is that launching of into the air. Yeah, liability is a big thing for corporations. Like, if somebody else is liable, then something breaks, somebody else has to pay for it. And a lot of corporations are definitely about liability because yeah, that's just how the world works. So what's something here that we could, like, this sort of train is obviously an exaggeration of stuff that needs to not be there, but we want to make sure that we still capture these. So I'm going to need to take a very quick bio break. I'll be back in about a minute, and we'll get back to fixing this. So I will be right back. Alright, well, if people are taking off, then hopefully you guys have a good one. So what I need to figure out is... Alright, so it's line 537 is why we are flying. So why is 537 where we are flying? So we are in our basic movement. So what has happened is we have flown up into the air just on our very basic movement, and we're let's do some Alright, so our movement distance was 159. Our impact normal was like this. So, and our slide normal was also like this. And our movement factor was this. Yeah, it was basically straight up. Our movement factor was basically straight up. The extra stick was 159 and the ground stick. So we were able to potentially stick for an extra, like, very large amount. I need a little bit more information. So we're going to say we didn't stick because the collision distance was greater than the max distance. And let's also print off the frame. And we'll just build that and run it again. Yeah, that'd be the funny thing. Like if I got ransomware on my main computer, I would just like reinstall Windows and just boot from my backup because I have absolutely everything important backed up onto another computer locally, and then of course remotely, because it's not a real backup unless it's in another physical location. So my house burned down. I'm just like, all right, cool. Get the insurance money, and like we'll be back on track here. Because that's the only real security is like you should just be able to just go up to your machine, smash it with a hammer, and just be like, all right, it's gonna take us X number of hours to get back to where we were, and we're gonna lose X amount of data, and that's it. But that's just my server engineer training, like working at Amazon, working at EA, doing big server stuff. It's like if that's not how you think, then you shouldn't be a server engineer. You shouldn't be in charge of that sort of critical infrastructure. Alright. So let's see. Didn't stick to the ground as the distance was 124, which is greater than 115? Wait, what? $537. I'm saying the distance was 124, but then alright, well obviously I need to print out the game frame here because we might not have the right game frame going on. Yeah, the other thing about like antivirus and security software is a lot of the times um, they will like to install browser plugins for you, and what'll happen is like the browser plugin will work by having basically the page call over like web request to its local self to like perform privileged operations. And if you get like some intern in there writing that security software, they'll make assumptions that the only thing that can call your browser plugin is like from your code that you wrote. And there have been so many issues where browser plugins for antivirus have basically exposed your entire computer to everything, because usually those plugins can operate, you know, completely trusted, and if there's a bug in the plugin, then it's all just screwed. Okay, so it didn't stick to the ground as the distance was 125, which is greater than 115. Well, obviously, like, there's something wrong here because we're saying the ground stick distance, 125 is greater than 115, which is just wrong. So that's the game frame. The distance was collision distance, and then we have max distance. So something is horribly, horribly wrong here with update snap to floor then? What is going on here? I must be going absolutely insane. We've got this 537, update snap to floor with floor stick distance. I guess it shouldn't be slide normal Z, it should be the actual. Actually, it shouldn't matter. Movement distance times movement direction vector. The movement distance was 159. Stick was 115 though. The extra stick, like movement distance times move direction vector. Why did we have the movement direction vector here? We changed it because it was the normal, because that's what we're moving off of. So, okay, that makes sense. Yeah, that makes sense because basically the issue is we don't want our actual like. So if we have a ramp like this and we run straight off it, which is basically what we're doing. Actually, yeah, I think we do want to use our movement direction vector. Let me try it out and see what it looks like. No, I fell off. I suck at wall jumping now. So we still have a little bit of hitching, and it has to do with when we weren't hitching before on those, so maybe what we can do is our movement direction vector z should be positive in these cases. Why don't we just rerun it real quick and see exactly where it's falling apart. So it's 630 and 699 and 730. So what is 630? 630 is what? Oh, it's actually 610. 610 is this. We're moving on an obstructed floor path. Alright, Pladdington, thanks for sticking around, and I hope you have a good night. So 610 is okay, this is not actually anything that is wrong. It's 1494? So that was right here. And that was with with 538. Line 538 was having us go into the air, which is again the basic sweep. The movement direction vector was pretty far in the Y and not far in the Z. So as a result, there was not much extra stick. Well, these are pretty ridiculous cases for this thing sticking. So, I mean, I guess what we want is maybe a multiplier on the extra stick, which is something like the movement distance So if you take the absolute value of the z and like actually we don't really need the, we just want like the movement distance multiplied by something. Like, you know, like like 0.2 or whatever, just be like the movement distance multiplied by that thing. Do we have the movement distance? We do. So we're just gonna hack it in here real quick and see what we can do with it. Alright, so this should basically, we take the speed that we're going to be running at, we multiply it by 0.2, and then we add that to our ground stickiness. And then we also have a z component, so we'll take the entire z component, we'll add it in there. So what that should do is very much allow us, if we like run off a ramp real quick, we can still stick to the ground pretty well. But otherwise, we can stick to the ground. Basically, the faster we're running, the more we can stick to the ground. There'll be some issues there, like if you're running along and you're going super fast, there's, you know, you will like instantly teleport to the ground. But if you're running up a ramp, you'll be able to like snap farther to the ground. But we can play a little bit with these sorts of things. And there's also kind of like, don't make geometry here that is just absolutely stupid to run on. So here we can run on just, basically garbage terrain. And we're absolutely fine. Now the question here is, did we actually... I made the character way too responsive, so now I can't do anything. Yeah, see, he immediately snapped to the ground there. Which is really, I guess, not what we want to happen. Because that's obviously like a... And it has to do with that... that speed. So we want it to cap out at something. So let's see if we can just decrease it a little bit and see if that is good enough for our movement. Because I don't know, movement for games is usually just a bunch of hacks all put together that make something that resembles something fun to deal with. Because it's not actually perfect, right? Like if you're trying to move around a corner or something in a game as a player, and like, there's like a block here and you're this player and you want to like move around it, and like, you hit just like stub your toe on something, you want the character to actually like nicely glide around it into this, pixel perfect square. So there's always just like little edge case shenaniganry you have to do just to make characters behave in a way that makes sense to your brain. Alright, so I think this works pretty well, actually.